Hello everyone, welcome back to the channel. Today we're diving into a fascinating and complex topic that often sparks debate among defense analysts and aviation enthusiasts alike: how Israel managed to move ahead of France in jet and missile technology, despite France once being one of Israel's earliest and most important military technology partners. This story is not just about machines and weapons, but about politics, strategy, innovation, and survival under pressure. To understand this shift, we first need to go back to the early years after Israel's founding. In the 1950s and 1960s, Israel was a young nation surrounded by hostile neighbors and under constant military threat. At that time, France was one of Israel's closest defense allies. French aircraft, especially the Dassault Mirage series, formed the backbone of Israel's air force. The Mirage Roman 3 was a game-changer for Israel. It gave Israeli pilots speed, altitude, and firepower that matched or exceeded anything in the region. French missile technology, particularly early air-to-air missiles, also helped Israel establish air superiority. For a while, Israel depended heavily on French know-how, spare parts, and training. However, this dependence carried a hidden risk. Israel's security relied on political relationships it did not fully control. That risk became clear in the late 1960s, when geopolitical winds shifted. After the Six-Day War in 1967, France imposed an arms embargo on Israel, cutting off aircraft deliveries and support. This moment changed everything. Overnight, Israel realized that relying on foreign suppliers for critical defense systems was a strategic vulnerability. Instead of collapsing under pressure, Israel chose a different path: self-reliance through innovation. One of the earliest examples of this shift was Israel's response to the Mirage embargo. Israel had already ordered Mirage 5 aircraft, but France refused to deliver them. In response, Israeli engineers reverse-engineered the Mirage design and created their own version, which became known as the Nesher. This was not a simple copy job. Israeli engineers modified systems, improved maintenance access, and adapted the aircraft to local operational needs. Later, this evolution led to the Kfir fighter jet, which incorporated a more powerful American engine and Israeli avionics. While France continued to produce advanced aircraft, Israel began something more important: building a domestic aerospace ecosystem that could innovate quickly and adapt to real combat experience. Combat experience became a key advantage. Israeli jets were not just tested in simulations or exercises, they were tested in real wars. Every conflict provided data, lessons, and urgent requirements that fed directly back into design improvements. This feedback loop accelerated Israeli innovation. Systems that didn't work were quickly replaced. Systems that performed well were refined and integrated across platforms. France, by contrast, operated in a more traditional defense industrial model, with longer development cycles and fewer real-world combat scenarios. Missile technology is another area where this divergence became clear. Early on, Israel relied on imported missiles, but embargoes and restrictions forced local development. Israeli engineers focused on creating missiles that were compact, reliable, and adaptable. The Python air-to-air missile series is a perfect example. Starting with relatively basic designs, Israel continuously upgraded guidance systems, maneuverability, and seeker technology. Over time, Python missiles became some of the most respected short-range air-to-air weapons in the world. What set Israeli missiles apart was not just performance on paper, but performance in combat. High off-boresight capability, advanced infrared seekers, and helmet-mounted cueing systems allowed Israeli pilots to engage targets in ways that older doctrines never imagined. France also developed capable missiles, such as the Magic and later the MICA. These were technologically advanced, but Israel's rapid iteration cycle often meant faster upgrades and more flexible integration with aircraft systems. Another critical factor was Israel's focus on avionics and electronics. While airframes are important, modern air combat is increasingly decided by sensors, data fusion, and electronic warfare. Israel invested heavily in radar, electronic countermeasures, and software. Israeli aircraft upgrades often transformed older platforms into highly capable modern fighters. Advanced radar systems, secure communication links, and electronic warfare suites allowed Israeli jets to see first, shoot first, and survive in heavily defended airspace. France also invested in avionics, especially with the Rafale program, which is an extremely capable aircraft. However, Israel's strength lay in modularity. Israeli systems were designed to be swapped, upgraded, and customized rapidly. This modular approach allowed Israel to integrate foreign components when useful and replace them when restrictions appeared. It also made Israeli technology attractive on the export market, where customers often want flexibility rather than a single fixed configuration. Missile defense is another area where Israel surged ahead. Facing constant rocket and missile threats, Israel had no choice but to innovate. Systems like Arrow, David's Sling, and Iron Dome were developed under real, ongoing pressure. While France focused more on traditional air defense and NATO-aligned systems, Israel pushed the boundaries of interception technology. Radar integration, command, control automation, and layered defense concepts became Israeli specialties. These systems were not just technical achievements, they were operational successes. Real-world intercepts provided credibility that few other nations could match. This reputation fed back into Israel's defense industry, attracting partnerships and investment. France's defense industry, while advanced, operated in a more stable threat environment. Urgency drives innovation, and Israel's urgency was constant and existential. Another often overlooked factor is human capital. Israel invested heavily in education, particularly in engineering, mathematics, and computer science. Military service also became a talent incubator. Elite units trained young engineers and operators to solve complex technical problems under pressure. Many of these individuals later moved into the defense industry or founded startups, transferring military-grade innovation into civilian and defense applications. France also has world-class engineers and institutions, but Israel's ecosystem encouraged risk-taking and rapid experimentation. Failure was seen as a lesson, not a disaster. Government policy played a crucial role as well. Israel actively supported domestic defense companies, understanding that technological independence was a national security priority. Procurement policies favored local innovation, even when it was expensive or risky. France supported its defense industry too, but as a larger nation with broader alliances, it did not face the same level of isolation risk. Israel's smaller size meant decisions were faster, coordination was tighter, and priorities were clearer. International partnerships also evolved differently. After the French embargo, Israel diversified its relationships, especially with the United States. This provided access to engines, funding, and advanced research, while still allowing Israel to develop its own subsystems. Rather than becoming dependent again, Israel focused on integration. American engines, Israeli avionics, locally developed missiles, and domestic software combined into unique platforms. France, meanwhile, pursued a more sovereign path with projects like Rafale, aiming for independence from both American and foreign systems. While admirable, this approach sometimes limited flexibility and export competitiveness. Exports themselves tell an important story. Israeli missile and avionics systems became widely used around the world. Countries valued their combat, proven nature, and adaptability. Each export deal generated revenue, data, and feedback, which fueled further development. This virtuous cycle accelerated Israel's technological lead in certain niches. France remained a major exporter, especially of complete platforms, but Israeli companies often competed successfully in subsystems, upgrades, and specialized weapons. Technology timelines also matter. Israel embraced software-defined systems earlier, allowing capabilities to be improved through updates rather than hardware replacement. Missiles, sensors, and electronic warfare systems became platforms for continuous evolution. This mindset mirrored trends in the tech industry more than traditional defense manufacturing. France eventually adopted similar approaches, but Israel's early start created momentum that was hard to match. Strategic culture is another key difference. Israel's military doctrine emphasizes initiative, flexibility, and preemption. Technology was designed to support these concepts. Jets and missiles were not just tools, they were integrated into a broader operational philosophy that valued speed and decision advantage. France's doctrine, shaped by NATO and nuclear deterrence considerations, emphasized different priorities. Neither approach is inherently better, but Israel's aligned doctrine and technology created a powerful synergy. It's also important to note that moving ahead does not mean completely surpassing in every category. France remains a top-tier aerospace power with advanced aircraft, missiles, and space technology. However, in specific areas like short-range air-to-air missiles, electronic warfare, missile defense, and rapid upgrade cycles, Israel carved out a clear edge. This edge was built not through sheer budget size, but through necessity-driven innovation, tight integration between operators and engineers, and a willingness to challenge conventional thinking. The story also highlights how political shocks can catalyze technological revolutions. The French embargo, intended to pressure Israel, instead pushed it toward independence and innovation. What began as a crisis became an opportunity. Israel transformed from a technology importer into a technology exporter and leader in critical defense domains. Today, Israeli jet and missile technology influences global defense trends. Concepts like network-centric warfare, active missile defense, and high-agility short-range missiles are now standard expectations. France continues to innovate and adapt, and in many areas the two countries still cooperate indirectly through shared partners and markets. But the historical trajectory is clear. Israel's move ahead was not accidental. It was the result of strategic necessity, cultural factors, combat experience, and deliberate policy choices. This story reminds us that technological leadership is not only about resources. It's about mindset, speed, and the ability to learn faster than competitors. As air and missile warfare continues to evolve with AI, hypersonics, and advanced sensors, the same principles will likely shape future leaders in this space. The lesson from Israel and France is that adaptability under pressure can redefine a nation's position in the global technology landscape.